Welcome to Taxonomy Online Mathematics. In this episode, we want to provide answer to this question under menstruation 1. One of the questions I chanced over in Pearson Mathematics, grade 11. So the diagram below shows 3 circles, where each of the radius of the circles is given as 4 centimeters. The center of the circles are labeled A, B, and C, such that the ABC becomes a straight line, and the line segment AB equals line segment BC, and they all equals to 4 centimeters, meaning that is a radius. So we have to work out the area of the shaded region. The area of the shaded region. So we can see that the first circle with the center A and the third circle with the center C is covering most of the surface of the second circle, leaving the outlet. So that is the outlet is what we are looking for. Now, if we were to know what diagram would this be, if this were to be a circle, we could also say that from here to here being the radius of the bigger circle become the diameter of this portion. But this doesn't look like a circle, so we cannot be able to identify that as a circle. So we need to be able to use the known part of a circle to see what will be the area out there. So looking at it, if we are going to have our straight line, which we are told passing through A, B, C, that is a straight line. So we know that a line from the center to any part on the circumference is a radius. So AB is a radius as 4 centimeters. And where they intersect also, if I draw a line this line is also going to be labeled as what? Radius, right? Because it is from the center touching the circumference. I think I'll have same here, here, here. So let's see. Good. So if you see the line, if in case I'm to label here D, E, F, G, you can see the line from D to E will be a chord. A chord is any line that joins 2 points on the circumference. So this is going to be a chord. FG will also be a chord. AD will be a radius. EC radius. EB radius. So since they are all radius, it means this and this will be equal. AB is also radius, so that will also be equal. So all the lines that we drawn to join the point B, D, E, F, G will all be radius. So I will take triangle ABD. That will be an equilateral triangle because the sides are equal. Since the sides are equal, it means each of the angle will be equal to what? 60 degrees. And the sides are already 4 centimeters. Whatever I have here is the same diagram here, the same, forming our hexagon. Good. So if I see this clearly, looking at the triangle DEB, which is going to be the same thing, that triangle is having a segment which is not shaded. There is a segment here that is not shaded. Don't forget, this segment and this segment and this segment are the same, because they are all formed by the same word, radius, or the same chord, if I may say. So it means if I know the area of this segment plus the area of this segment, if I subtract it from the sector, you know, a sector is a region between 2 radius and an arc. If you have a radius and an arc, you call that a sector. If you have an arc and a chord, you call that what? A segment. Meaning the sector is made up of segment and a triangle. You see, this is a sector which is made up of a segment and a triangle. So if I want to combine them, segment plus triangle equals to a sector, meaning the segment that I am looking for to subtract will be equals to the sector minus the triangle. So it means if I know the value of this segment is going to be the same as this, the same as this, the same as this, the same as this. So I have two sectors that have the same calculation because they have the same angles, they have the same length of side or radius. Then it means 2 of the sector minus 1, 2, 3, 4 of the segment will give me the area of the shaded part there. So I can try to find the area of, first of all, let's say the triangle. So we know area of a triangle which is inclined to produce an angle without a height will give us half AB sine theta. That is the formula. If you check my playlist, I have a tutorial on how to find the area of all the triangles, not using the half base and height. So this AB stands for the sides, the two sides that are inclined, which is A and B. These two sides inclined to produce an angle what? 60. And don't forget, this AB in this case are the same, 4 centimeters each. The angle inclined at the center is going to be 60 degrees. So your area will be 1/2 times 4 sine 60 degrees, which I believe this will be half of 4 will be 2 times 4 will be 8. So I'll be having 8 times sine 60. You can use the hand. This is 0, 30, 45, 60. For sine, we are picking the square root of 3 divided by 2. So that will be square root of 3 divided by 2. These two can divide that. So you have 4 root 3. Since it is area, centimeter squared. That area of the triangle is the same for all the 6 of them. Alright. Then what are we looking for again? We need to find the sector so that we can subtract the triangle from it to get a segment. So area of a sector, we know it is concerned with the angle produced at the center, and that angle is going to be 60. So we have it as theta out of total angle 360 times what? The area of a circle. And area of a circle is going to be pi r what? Square. So per substitution, your theta is going to be 60 degrees. Pi times what? R, which is the radius. And the radius is 2. So 4 times 4 times what? Pi. Let's see how best we can cancel that. 10 will go and cancel, leaving 6 and 36. 6 will go there 1. 6 will go here 6 times. Then we'll be having 1/6 times 16. 16 over what? 6, which will have a common factor of 2. So 2 into 8. 2 into 16 will be what? 8 pi over 6. And 2 into 6 will also give us what? 3. So in all, our sector is known. Our triangle is known. What are we looking for? We're looking for the segment. So area of a segment is going to be area of the whole thing, which is the sector, minus the area of the triangle, which is the same for all of them. So now we do our substitution, which is going to be area of a sector. So let's do area of a segment equals to, I think it will be 8 pi out of 3 as a sector, then minus the triangle, which will be 4 root what? 3. I think this will also be centimeter squared. Yeah, centimeter squared. So if this is the area of the segment, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This segment, they are all the same. But what are we looking for? We are not looking for the segment per se, but we are looking for the shaded region, which is made up of 2 sector, this, plus another sector. Then we subtract segment from it. So shaded region, or the area of shaded region, is going to be 2 of the sector or sectors minus 4 of the segment. I believe you get that, because it's a complete sector, then another complete sector, and out of that sector we are taking away a segment and a segment. So know the area of the sector, subtract the segment, 2 segments from it, then you have that small portion that will be shaded. So this is going to be 2 times sector. Where do we have that? That will be 8 pi on 3 minus 4 of a segment, which is going to be 8 pi on 3 4 root 3. By multiplication, this will give us 16 pi on 3. So this will multiply this, leaving 3. Then minus, this will be going here to give us 32, right? So 32 pi on 3. Negative become positive. So that become plus 16 root 3. So what do we do? We have pi, we have rational. So what do? We compute the pi together. Since they are fraction of the same denominator, we only go ahead and subtract the numerators, meaning 16 minus 32. That will be a negative 16. So since this portion will be negative, I'll write this first as it's going to be first of 16 root 3, which is this one, then minus 16 pi divided by what? 3. Do you get that? It could have been negative 16 pi over 3 plus 16 root 3, which is the same thing. Just want to bring the positive before the negative. So this will be your answer. Put in bracket centimeter what? Squared. Or we need to put in the value of pi and that of what? The rational, irrational root 3. So if you find that in the calculator, we'll be having here will give us 27.7128. Then 16 times pi, which is 3.142 divided by 3, will also give us 16.7552. So per that subtraction, we have 10.9576 centimeter squared. That is to 4 decimal places. To 10 whole number will be, to a whole number will be 11 centimeter squared. To only 1 decimal place will also be 11.0. To 2 decimal place will be 10.96. And to 3 decimal places will be 10.958 centimeter squared. I believe this is clear when they come to mensuration 1, using the area of a triangle, sector, and a segment. Using the ideas of equilateral triangle as well, we are able to find a solution to this question. If you have any other reservation, see me in the comment section. Share this with somebody on your contact list encourage them to subscribe to the channel. Let them turn on their notification bell to receive notification anytime a new video is uploaded. We are in together. I teach, you learn, we grow together. Like, share, and comment. Bye-bye.